Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello. Uh, Hello everyone. Hello Nikhil. Hello Naikaj. Yeah, can you please confirm I'm properly audible and visible? And I'm sharing my screen as well, so kindly confirm that. Okay, I think today will be the fifth session. Yeah. So this is the fifth session of January, I suppose. Okay. Yeah, no worries, Naikaj. Yeah, all you have to do is keep practicing, and that would be enough. Okay. Yeah, I would request everyone to kindly write their name in the chat box to confirm your presence, and then we can very quickly start. Yeah, it is the tree session which is going right now, and in fact, there is a dynamic programming session also going on Thursdays and Friday, taken by another mentor. So you can check that out as well. Yeah, so very good evening. I welcome you all to the fifth session, and today will again be a practice session like the last two sessions. Okay, so in the last session, we did a few of the iterative versions of various traversal techniques of binary tree. And in this session, we will also be doing a similar kind of question. The first will be the vertical order traversal, and the second and third would be to finding the top view and the bottom view. Basically, the concepts used for the first question will be utilized to solve the second and the third question as well. Okay, so any doubts? And did I give a homework problem in the last session? I suppose I did not. Okay, yeah. So also, I would request everyone to kindly like the session, the streaming that is going on. Okay. Okay, Naikaj. Yeah, Naikaj, do you know about vertical order traversal? This is a question actually, so let me paste the link of the question in the chat box. This will be helpful. Yeah, you can just Google the question as well. You will find the GFG practice portal itself. Okay, so in this question, what exactly is the question saying is that you are given a binary tree, and in fact, you are given a binary tree with the root. Okay, so you have to return a vector consisting of the vertical order traversal. It means that a diagram has been given explaining the vertical order traversal. So we will proceed from the left end to the right end. And in the first vertical, we observe that a node of node number 4 is present. So we will be outputting the value 4 in the beginning, then the node 2, then the node 1, 5, and 6. And since 5 and 6 are overlapping, so we will output 5 because 5 is smaller than 6. And 1, 5, and 6 are lying in the same vertical. Then 3 and 8 are lying in the same vertical, so 3 and 8 comes after that, followed by 7, which lies in vertical number E, and then finally 9. Okay, so this is how we will progress from the left vertical end to the right vertical end, and meanwhile outputting all the node numbers, okay, in the form of a vector. Okay, it should be a 1D vector because we don't want to make it 2D-dimensional. Yeah, and the space and the time complexity should be a capital big O of n. So and the auxiliary space should be also big O of n. Number of nodes will be 10 to the power 4. Yeah. So any idea, anyone, how what exactly are we going to use to solve this problem? We already know about iterative versions of pre-order, post-order, and in-order traversal. So can we utilize those concepts to solve this? Yes, Naikaj. What are you saying? There is one concept called the horizontal distance, which we can take help from that. Horizontal distance. What do you mean by horizontal distance? The concept of horizontal distance. I don't think I have heard about this. Like maybe I have heard, but by a different name. Can you explain that? Yeah. Yeah. So since you all are thinking, let me just tell a few pointers about this session. So this is a tree session which is going right now on the GFG practice channel. So basically, mm, yeah. So we had a graph series in the month of December, and in the month of January we are having a tree series. So this is 2 days a week on Mondays and Tuesdays at 10 p.m. Okay. So tomorrow will again be a session, but and tomorrow's session will be consisting of binary search trees, and in short form we call that BSTs. Okay, and after BSTs are done, we will again focus on solving questions. Okay, so you can expect around 2 or 3 problems on a daily basis, like on the days we are having a session. And you can also attend a dynamic programming session, which are going on Thursdays and Fridays. Okay, and that is also, I suppose, at 10 p.m. So you can check that out as well. So this session is being organized by another mentor at Geeks for Geeks. Okay, and yeah, this is my introduction. My name is Gaurav Kumar Shaw, and I'm presently in my third year at IIT Kharagpur. Okay, so this is about me. Okay, Chinmay is saying that okay, Naika is saying there is one there we use BFS, distance from root. Horizontal distance is equal to call the distance from the root. If you assume root as 0, then left will be -1 and right will be +1. Okay, yeah. Yeah, that is correct actually. Yeah, in fact, we will use that concept only to solve this problem. Okay, so I have already made up the slides as well. Okay, yeah. So since we are starting from the root and we are taking the root to be at a vertical number 0, so what you're calling as the horizontal distance, I'm calling it as the vertical number. So if I'm taking the root to be at present vertical number 0, all the verticals present to the right side will be positive numbers, that is +1, +2, and +3. And after that, all the verticals to the left side would be negative numbers. Okay, so this is how we will proceed. Okay, yeah, and after that, what should we do? Root should be 0, and if you go root left, and it will be our yes, Naika, you are also correct, and Shinma, you are also correct. Yeah, in fact, I would be using that concept only to solve this question. Okay, so what do we say here is that we have to make 2 parameters. The first parameter would be the vertical number. Okay, and the next parameter would be the node number. Okay, or in fact the level number, I should say. Because why do we need vertical number as well as a level number? Because the vertical number will help us know in which vertical it is lying, the node is lying, and we also need to know the level number as well. Okay, so there will be 2 parameters we need to take care of. So can anyone tell me what should be the vertical and the level of root 1? Okay, Naika is saying that if we will use map of intent vector, and what will you store in the first int, and what will you store in the vector? Can you tell? Okay, Naika is saying that you will use an unordered map of int vector int. Are you sure you will use an unordered map? Like it is always advised, like whenever we are doing DSA problems, it's better to use map than unordered map because in worst case complexity it will go off till n, O of n only. Okay, like when you are doing code forces or something like that, it is advisable to use unordered map. Anyway, both will be correct actually, so no worries in that. And in fact, actually, what happens here is that if you are let's see that. Okay, level and level data. Okay, yeah, Naika, yeah. So let's see. So as I told, int stored the horizontal distance. Okay, so let me say. Okay, so basically, as I said, we will be having two parameters, namely the vertical. Yeah, so namely the vertical and the level number. So why we need that? Because the question is saying that we have to find the vertical order traversal. So the node number, the root, that is the node number one, will have a marking called 0, 0, 0, because root 1 is present at level 0, and it is also present at vertical number 0 according to our nomenclature. So for our root, I will mark 0, 0, but for its left child and the right child accordingly, what I will do, I will increment the level by 1, because whenever we are traversing from the root to other parts of the nodes, other part of the tree, we are basically increasing our level. So from root node, we go to the left child and we go to the right child. So what happens is that when we are going to the right child, the vertical is increasing by 1. So which means the vertical is becoming plus 1. And when we are going to the left child, the vertical is becoming minus 1. But in both the cases, the level is increasing by a plus 1. So for node number 2, the mark will be minus 1 comma 1, and for 3 it will be 1 comma 1. Okay, so I hope this concept is clear about how we are marking the individual nodes at every point. Okay, so Naika is saying that first use queue node int. Okay, yes, we will use a queue because we have to in fact do a level order traversal. Yeah, I'm coming to that. But I wanted to make you understand the concept first, and then we will proceed to the implementation part. And one more thing we have to take care is that if two nodes are present on the same level, for example, the node number 9 and 10. So these two nodes are present on the same level. So in that case, what will happen? We will take that node which is present, which is having a smaller value. We will take that first into consideration. For example, when I was dealing with level number 3, my output was 1, 9, 10, and 6. So 9 is coming before 10 in my actual output. So because 9 has a smaller value than 10. But in fact, 9 and 10 are both lying on the same vertical. Okay, and they are overlapping with each other, and they're lying on the same vertical as well as on the same level. So this should be taken care of. Hmm. So this was about the concepts. Now let's look into the implementation. Yeah. So first of all, we need to do a traversal. Okay. Now we need to make sure that our traversal is following every verticals. So the best traversal that come to our mind is a level order traversal, because we need to go level wise level as well. Okay. So what we can do basically is that we will use a few data structures. So as you all have already mentioned in the chat that we will be using a queue and we will be using a map. So the queue data structure will contain two values. The first value would be the address to the node. So I will be storing the node reference of the node in my queue. And along with that, I will be storing the parameter values, the vertical number and the level number, because every node is associated with two values. So my queue would look something like this. So this is a queue. The first would be node and the second would be a pair which contains two values. The first value would be the vertical number and next value would be the level number. So this about the queue it is done. Now we have map. So in map we got the first parameter in the map is the vertical number. Why do we need a map basically? Is that we have to make sure that for every vertical we are calculating all the nodes present in each individual level. So for let's say any vertical x, there are many levels. Okay, so for every vertical x, we will have level 1, level 2, level 3, and for every level we will have few nodes. Okay, so that is the reason. So for every x, we will have multiple levels, and for every level, we will have multiple nodes. So that is the reason we are using map of int. The first int is signifying the vertical number. The second parameter is again a map because I need to store the levels as well in a map only. And the second parameter of the second map is a multiset because it will be a multiset because there can be repeated values actually. Okay, so that is the reason we are taking a multiset. We can also take a set, but we are not sure that all the values are unique. Okay, but that is the reason we are taking multi-set because in multi-sets, you duplicate values can be stored, but not so in the sets. So I hope this up till here it is clear. Chinmay, any doubt? Any Nikach? Yeah, we will be doing VFS traversal only, Nikach. So, like more specifically, you can call the level order traversal. Okay, because we are actually using the concept of level order traversal to solve this. And just taking care of some fancy data structures to implement the logic. Okay, yeah. So this was about the movement part. That whenever we are moving in the level order traversal, if we are going right, we will increment our parameter by +1 and +1, and if we are going left, we will do a -1 and +1 for the vertical and the level. Okay, so this is the question. So let's try to have a look at the code. Okay, so give me a minute. So Arbaz is saying that why can't we use DFS? So what will happen in DFS is that DFS will actually not help us to solve this because DFS is a depth first search, the recursive algorithm. So it will keep on going on its depth, but we don't need that value. Okay, so for the interest of the question, what we need, a level order traversal is actually helping us. So that is the reason we are using a VFS kind of approach and not a recursive approach. Okay. And in fact, can anyone tell the time complexity of the approach that we just discussed? Wofen, are you sure? I don't think so because actually we are taking multiple maps and everything. So just have a look at it, what it should be. Yes, Naikaj, you are correct. We can't use DFS because we need to print level wise level. Okay, Naika is saying for map, it is normal for insert. So as I discussed, the first step would be to declare a data structure called map. And this map, the first one would be the vertical number. Then again, we will have a map. And for the second map, the first parameter would be the level number. And for every level, we need to store all the nodes. So we have declared this data structure to nodes. After that, as usual, we will need a queue to store the to do the level order traversal. The queue will contain the reference to as well as the parameter values, which will be the which will be the vertical number and the level number. Okay. After that, we will push the value 0, comma 0 inside our queue data structure. Why do we push? Because we are doing a level order traversal, and as usual, we need to push the root and the 0, comma 0 part. Okay. Later, after that, we will run a while loop, the standard while loop for level order traversal, and the while loop will run as long as our queue is not empty. We'll take the top element from our queue like that. Okay. Now we'll do vertical order. Check the verticals. So basically, what we will do, we will insert that into our say. So in x is basically the second p, which is the value of first, which is the vertical number. So we are taking the vertical number. In the first iteration, the vertical number would be 0. Okay. And the y is also level number. So we are inserting that into our map. So this is the way we insert. We write nodes of x comma y dot insert is equal to temp dot data. So now we are inserting that into our data. Okay. So this is how we are building the answer. Then what we do, we go to the left first and then we go to the right. So if we go to the left, our vertical is decreasing to -1. That is the reason we are putting x minus 1 and y plus 1. And in case if you go to the right, our vertical is increasing by plus 1. Level is also increasing. So these two if statements is basically uh, pushing it into our queue, the next levels that it's going to iterate over. So this part is done. So we are just iterating over a given particular element we are taking from the queue, pushing its right and the left level with the appropriate level number and the vertical number. And whenever we are actually accessing any element from the queue, we are just pushing it inside of a map called nodes appropriately. Okay. For every first we are putting the vertical number, and for every vertical we are going all its level, and for every level we are pushing all its level. So this is how we build our answer. Now, finally, we need an answer vector as well. Okay, so basically in this question, it is said that we are supposed to return a single answer only. Okay, so a single vector answer. Okay, not a two-dimensional vector. You can see that if I try to submit this problem, this will not run actually. Yes, so let's try to have a look. This would be capital N. Let's see. Yeah. So this comparison error is basically saying that we are supposed to return. Okay, I don't understand why map and inside map. Okay, why do we need a map? Okay, so if not map, can you recommend any other data structure that will help us solve this concept? We need to take care of every vertical, and for every vertical, we need to take care of its level number, and for every level, we need to take care of all the nodes present in that level. We have to take care of these three things. Can you recommend any other way you can do that? Can you do that with the help of vector? I don't think you can. That is the reason we are taking a map. Okay, so Suppose that you are experiencing a bit lag in the streaming. Sorry for that. So there is a small error in this, and can anyone tell me what is the error here? Yeah, Naika, you're saying that you did not use multi-set and all. Actually, yes, we can do it without using multi-set, but the idea was that basically there can be repeated nodes, right? When you're inserting inside in case of a set, it will not take care of it. That is why I thought of using multi-set because it was actually a good idea. Okay. So, but right now I'm facing into a bit of error. Let me see why it is. Okay. So, maybe what we can do basically, keep this code here. We'll come back to it later. The other question was that we have to write the top view of binary tree. And I want to know how should I deal with this question? This question and the previous question are all same. In fact, the previous this question is a subset of the previous question. Okay, so any ideas how we'll do that? Yeah. So let's discuss the top view of binary tree first. And meanwhile, if anyone Naika, you are giving your code link. That's great, Naika. You see, I'm checking that out. Okay. So let's see that the top view of a binary tree. So basically, this is a tree given. We only have to output the top view. So how does the top view look like? We'll output the node number 4, then 2, then 1, 3, and then 7. Okay. So and as usual, we'll proceed from the left hand to the right hand and we'll do vertical wise. So the for the vertical, we have vertical number minus 2 and for minus 2 we have row number 4. So we'll do that. So how is this question related to the previous question? Can you tell me? Like you just do a small bit of modification to the concept. I don't think actually that comment I can share the code in the comment because comment has character limit. Okay, the entire code won't be pasted. Okay, let's come back to the question then. We will look at it till the end. Otherwise, we can go over the code tomorrow as well. No worries. Okay, so let's come back to this question, the top view of the binary tree. Now, in the previous question, we were outputting everything that was coming on every vertical line. But in this case, we will only output the first node that is in every vertical line. So you can see this vertical line which contains 2 and 6. In the previous question, we had to output 2 and 6 both. But in this question, we will only output the first node, that is 2. Okay, so how to do that? Yeah, Nikaj, hello Vaishnav, and hello Chinmay. And okay, previous concept distance. Yes, we have to use it only, but tell me what small modification that we will do that will help us solve this problem. Okay, so let me tell you. The first we'll do is basically we have to do a level order traversal. So we will declaring a queue, we will store the node number, and we will also store the level number and the vertical number and the level number. Okay. Do we actually need the level number here? Because it doesn't matter. We only have to put the first node that is coming in every vertical. And as soon as we are encountering a first node in every vertical, we will just print it out. So in this case, we actually do not need a level number. Okay. The concept is we do not need a level number in this case. Only the vertical number would suffice. Okay. We need a level number. Only the vertical number is enough. Because we don't care actually. So we are interested in very close node. The vertical number is enough. Okay. So let's see the code implementation. You will understand it perfectly. So in this case, declaring just a simple map would be enough because the first parameter of the map. So the first parameter of the map is containing the vertical. Okay. And the next parameter of the map is containing the first node of the vertical. Yes. So this is containing the vertical and this is containing the first node of the vertical. So as usual, our queue will contain only two values. The first will be the node values and the second one will be again the vertical number. So our queue is containing node reference and the vertical number. So we'll run a so as usual, we will basically push the value root and the value 0 inside our queue. After that, what we'll do, we'll run the standard while loop of level order traversal. We'll take the front element from our queue, pop it out. Okay, so now the node is the id dot first, and the line is basically the vertical number. It is id. Now what we'll do, in the map, whether that is present or not. So mpp.5 line is equal to mpp.5 means it is not present. So that vertical we are encountering for the very first time. So we will store the data. Okay, and if it is not already present, it will do nothing because if it is already present, it means that we have already encountered the very first node of that vertical. So it makes no sense to proceed forward. After that, what we will do, we will go to the left and we will go to the right. For the left part, as usual, we will decrease the vertical by 1. The right part will decrease the vertical by 1. Decrease the vertical by 1. And there is no concept of level in this question. Okay, so this is basically an easier version of the previous question. In the previous question, we need to take care of the level as well as the vertical number. But from this, only the vertical number would suffice. So see, My voice breaking like that. So can you please confirm that I'm properly audible and my voice is also not breaking? So you can see that this question has been successfully solved. Okay. So there is also another similar concept called the bottom view of binary tree. Okay. So how do we do it? So in the top view, we were only interested in the first node that we were putting inside our map. Now we are only interested in the very last. So what we are doing, we will keep on putting the map one over the another. So let's say I pushed into a map, but again we encounter a new value. So we will replace with the previous one. So at the end, when the while loop will get over, the iteration will get over. The value which is remaining in my map is basically the very last value. Okay, so this is again a very similar concept. So, Michael, can you please confirm that whether my voice is still breaking or it's okay? And in fact, we have 10 people. So we would request everyone to kindly like this session and subscribe to the GeeksforGeeks Practice YouTube channel because we are planning great quality content to be delivered in the few months. In fact, this would certainly be very helpful for your preparations of your internship and placements interview. Okay. So this was about, let's look into the bottom view. Bottom view of a binary tree. Okay. Now, this, I suppose I am audible right now. By mistake, the mic got switched off. But let's not worry about that and see this question. So, in fact, can anyone just spot the error? Why it's an issue here? Yeah, Naikaj, apology for that. So, what exactly we are missing here? Okay, let's look into the editorial code actually. So let's try to submit the editorial code, another code. We will be having a session tomorrow, and I will discuss the error in this code, why it is not working tomorrow after I figure that out. And meanwhile, what you can do, this is the editorial code which is present on the GFG platform itself. Okay, so in this question, what is happening? They have only considered a map, and the first letter is basically the vertical number, and in that case, it is actually maintaining a vector. Okay, so this will actually work. Let's see. Hmm, should be present here. Yeah, as you can see, this code is passing. So, yeah, this is the editorial code. It should pass. Okay, so in my previous code, I guess there was small error in dealing with the rest was not declared. Actually, it is declared, so that's not the issue. I declared the rest. Okay. So this is actually the same similar kind of implementation, but the data structure which I took was kind of very complicated. In that case, it was I was not able to return a single vector. In fact, I was returning a vector. But this implementation is quite straightforward. Okay, so this was all about today's session. And if you have anything to ask, you can write in the chat box. I'm here for a few more minutes. And after that, yeah. So tomorrow will be a session on binary search trees. In fact, binary search trees is actually a quite small topic. So we will also continue with practicing problem, and definitely we'll look into the error for today's problem. Okay. So today was a practice session, and we discussed three important problems. This is the first one of was a vertical order traversal, which and the second and third problem was a easier version of the first problem, which took the similar concept but in a very easier manner. Okay, so this was about today. Yeah, and yeah, so let's see you all tomorrow. And I would request everyone to kindly like the streaming as well as subscribe to our channel as well, because we are planning to provide great quality content over the next few months, which would certainly be very helpful to you all. Okay, so yeah, good night and see you tomorrow then. Bye bye.